Okay, so in this problem, what we have is a car traveling on a flat road, traveling at 35 meters per second, and the car can stop in a minimum distance of 24 meters. Now the same car on a slope on the same type of road surface, but now at a 30 degrees slope to the horizontal, is traveling at 10 meters per second. This 10 meters per second is slower than the 35. However, the question is, what is going to be the minimum stopping distance of the car? Now, in order to figure this out, what we need to do is we need to figure out what mu is. We don't know what mu is. So in order to figure this out, what we got to do is do the free body diagram of the car on the flat road. Now, what we realize here is that a lot of students will actually do this wrong by putting a force in this direction in the direction that the car is going. This is absolutely wrong. What we would do, maybe I should start this over again here. There's a bit of messiness here. What we should do is realize that the only force acting on the car is the force of friction. I'm going to say this is the positive direction. So if I now say the sum of the forces on the car is equal to F net, which is equal to ma, I'm going to have that the only force on the car is the negative force of friction, and that's going to equal ma. And that negative force of friction is actually negative mu mg. So I can now cancel out m. Obviously, I haven't given you the m. And so now, in order to find mu, we can say that's just equal to negative a over g. But what's a? Well, in order to find a, we can say, all right, listen, let's use this equation here. V final squared is equal to V initial squared plus 2a delta d. We know the final velocity of the car to be 0 because it comes to a stop. The initial velocity of the car was given as 35 meters per second. The delta d of the car is 24 meters. Therefore, I can calculate the acceleration. Acceleration is equal to v final squared minus v initial squared divided by, taking this equation and just doing some algebra on it, divided by 2 times delta d. Therefore, I have 0 minus 35 meters per second squared divided by 2 times 24. Now, that's going to give me 35 squared, 48 divided by, gives me 25.5. So, I've got negative 25.5 acceleration, which is meters per second squared. Now, once I have that, I can calculate mu here by saying, all right, negative mu is negative 25.5 divided by 9.8. And that's going to give me 9.8 divided by, so holy smokes, this is a gigantic coefficient of friction, 2.6. Now, in real life, you can't really have anything that humongous. However, let's continue with the problem. At this point, we have to go to the slope situation, and we say to ourselves, okay, we have friction going this way, and we have gravity, mg sine theta, going this way. And so let's figure out what we're looking for here is delta d. In order to get delta d, we're going to need a. So in order to get a, let's do summation of the forces again, is F net. And in order to get that, we'd go, and let's say this way is positive now. So we'd say mg sine theta minus force of friction, which in this case is mu mg cosine theta. And that's going to equal ma. Now, let's cancel out the m's. and we've got A. And so I can just say A is sine 30 minus mu, which was 2.6, times cosine 30, all times factoring out the G, which is 9.8. That's A. Now, what do I get for that value? 30 sine is 0.5, and then 2.6, enter, 30 cosine times, subtract, and we get 9.8 times. We get an acceleration of negative 17.2 meters per second squared. Therefore, once again, using this equation, v final squared equals v initial squared plus 2a delta d, solving for delta d, we'll get this divided by 2 times a. Final velocity 0 again. Initial velocity was 10 meters per second, divided by 2 times negative 17.2. And our final answer is 100, enter, 2 divided by 17.2 divided by, our answer is 2.9. So that's a really short stopping distance because the coefficient of friction is so humongous. Anyways, thanks for listening. That's the end of this problem.